All right, y'all. In this video, we are going to continue the section 4.3, and we'll just kind of see how far we get. We may end up finishing it here. It just kind of depends on how long the video takes. So let's talk about what a reference triangle is. So reference triangle is a triangle that you make by dropping an altitude from a given point to the x-axis. So if you have a scenario where you're looking at one of those angles, let's talk about those angles that we were seeing in the last video. But say that you have something in standard form. You've got this point that you're looking to, right? And we talked about the fact that you can create a triangle. That reference triangle is this triangle. So you've already been drawing that a little bit and not really realizing that's what you were doing. Now, reference triangles are not just in quadrant 1. Reference triangles are in any quadrant. So let's talk about how that looks if I'm working in a different quadrant. If my initial side is always on the positive x, but let's say that I open up over here. So my reference triangle is actually made by dropping from a point straight down. So although I would be looking at this angle measure, right? That's the angle in that scenario. The reference triangle is actually this triangle right there. Okay, so I know that's a little bit weird and it doesn't feel like that should be right, but it is. Now, with that being said, the reference angle is the angle with the vertex at the origin in that reference triangle. So what we're going to do is say if I have this little reference triangle, the angle that we are actually going to look at is here on this side. Okay, so even if the angle they've told me is in here, right, the angle that I'm going to actually work with is here inside the reference triangle. Okay. Let's also talk about what we have going on with our trig signs. So I want to remind you guys of the relationships we talked about in the last video, where if you have sine is y over r, cosine x over r, tangent is y over x, right? Well, in a quadrant, I need you guys to think about what is positive and what is negative. So if you look at your xy axis, right? Over here, my x is positive and my y is also positive. Over here, my x is negative while my y is positive. So this is quadrant 1, quadrant 2, quadrant 3. If I could draw 3. Quadrant 3, I have my x is negative and my y's are negative. And then quadrant 4, my x's are positive and my y's are negative. Okay, so what I want us to do is think about how that affects our trig values. For sine, when they put y over r, in that first quadrant, the y is going to be positive. The r, we're going to assume that r is always going to be positive because of the fact that it's just talking about the distance in there. So let's let r always be positive. Sorry, I've got an announcement.
Teachers and staff, pardon this interruption.
Okay, I paused the video so it wouldn't get the whole announcement on there. But so here we go. The r's, like I said, we're going to let those be just positive because they're talking about a distance. But your x and y, those can be positive or negative because of where they land in the coordinates. So if you're working with sine in quadrant 1, that's y over r, a positive over a positive, right? In quadrant 1, cosine is also positive because x is positive over r, a positive. Tangent would also be positive because y over x, positive over positive, that's positive. So in this first quadrant, all of my things are positive. Okay, all my trig values are positive. Now let's look over here in quadrant 2. In quadrant 2, my x is negative and my y's are positive. So think about how that affects your trig ratios. Sine is y over r. Well, that would be a positive over r, a positive. So that's positive. And cosine would be x over r. Well, x is supposed to be negative. If you take a negative divided by a positive, cosine is actually negative in this quadrant. Look at tangent. y over x, positive over a negative, actually results in a negative. The only trig ratio that's positive in this second quadrant would be sine. So we're going to say sine positive. Okay? Look down here in quadrant 3. They're both negative. If I take sine, y over r, that's a negative over a positive. That's negative. Look at cosine, x over r. Negative over positive, also negative. But look at tangent. Tangent is y over x, negative over a negative. Tangent is actually positive in this quadrant. My last quadrant here, quadrant 4, we have x would be positive, y would be negative. So look at how that affects your sign. Sine would be y over r, negative over positive, so sine would be negative. Cosine is x over r, positive over positive, which is positive. So cosine is positive in this quadrant. Look at tangent, y over x, negative over positive is negative. So the only one that's actually positive in this quadrant is cosine. So this is something that we are going to use to help us with finding our sine, cosine, tangent values. In quadrant 1, all of the trig ratios are positive. In quadrant 2, only sine and its reciprocal cosecant would be positive. In quadrant 3, only tangent and then cotangent by default are positive. And then in quadrant 4, cosine and by default secant are positive. And so that's what you're seeing here when you're writing these notes with the this thing right here, A, S, T, C. Quadrant 1, 2, 3, and 4. And a mnemonic device kind of that we use to help us remember this order is this little phrase right in here that says all students take calculus, ASTC. And literally I still do it. Whenever I'm trying to figure out my stuff, I draw an XY grid and I just say ASTC, all students take calculus. And it just helps me remember the order or the which trig ratios are positive in which quadrants. Okay, so with all that being said, my goodness. Okay, with all that being said, let's look at example 4. It asks us to find all 6 trig functions of 7 pi over 4. And it should go without saying this is without a calculator, okay? So to find all 6 trig functions of 7 pi over 4, well, first thing would be helpful is to draw 7 pi over 4. So I have 7 pi over 4 should have that initial side over here. 7 pi over 4, I want you guys to think about the way that this cuts up your little rotations. 7 pi over 4, I know that 4 pi over 4, a whole pi, would be 180 degrees halfway around. 2 pi's, or 8 pi over 4, would be all the way around the circle. And I want you to remember that pi over 4 cuts these little quadrants in half. Okay, so pi over 4 would go straight through the middle, being 45 degrees. 3 pi over 4 would be here. 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4. And it went all the way around. Okay, but in order to find the 6 trig functions of this, we're actually going to use a little reference triangle. So what we'll do is we're going to drop an altitude straight to that x-axis, just like that. Okay. So what I need then is if all of this is 7 pi over 4, this little angle inside my reference triangle, I'll draw this a little bit bigger, but that angle inside that, well, I can't draw. Inside my reference triangle would just be pi over 4. 7 pi over 4 plus pi over 4 is a whole rotation, 8 pi over 4. Pi over 4 is the same thing as 45 degrees. So do you see where I'm going with this? We're going to use a special triangle, knowing that this side, the ratios 1, 1, and square root 2 can be used to find those trig ratios. Okay, so we're using all of this stuff with 45 degrees. Also, another fun fact is we need to make sure we're keeping our trig ratios straight. Since we are not in quadrant 1, we need to make sure that we are careful about knowing which trig ratios are positive and which ones are negative. In this quadrant, the only one that's positive is cosine. So the only thing is cosine, and then it's reciprocal by default. Everything else should end up being negative. All right, so let's look at sine of, we're going to call it 7 pi over 4, because that's what allows us to drop it into this quadrant. But then from there, to get the numbers, I'm going to look at actually this right triangle and use this reference angle. So opposite over hypotenuse, 1 over square root 2. Keep in mind 7 pi over 4. Sine should be negative in this quadrant. So this is a negative 1 over square root 2, which we can rationalize. This is negative square root 2 over 2. All right, let's look at cosine. Now, cosine is the only one that should be positive. 7 pi over 4. So I want adjacent over hypotenuse, 1 over square root 2. And this one should be positive because of the fact that we're in this quadrant. So this would be positive square root 2 over 2. All right, tangent, 7 pi over 4. Tangent, opposite over adjacent. But again, keep in mind this one should be negative. So negative 1 over 1, which is negative 1. For our reciprocals, cosecant of 7 pi over 4, we're going to flip that sign. Keep in mind we got to keep the sign with it. So negative 2 over 1, or square root 2 over 1, which is actually just negative square root 2. I'm running out of room. But that's what that would be simplified. Secant, 7 pi over 4, should be just positive square root of 2. And then cotangent, 7 pi over 4, negative flip 1 over 1. Negative 1 over 1 is still negative 1. So we end up with our 6 trig ratios for that. But we use a reference triangle to do it. All right, look at example 5. Again, we're doing these without a calculator. This time it's just one trig thing for each angle instead of doing all 6 for something. So this just gives us a little bit more practice of varying up our problems. We're going to evaluate this without a calculator. Okay, so right here we've got sine of negative 210. So one thing I would do again is draw the picture of what that's going to look like, and then make a little reference triangle off of it. So here's a little quadrant thing, and we want to think about what does negative 210 look like. Well, the initial side always starts here, and that's going to open out to be negative 210. So we should open in the negative direction. And it should be, let's see, 180 would be to the other x-axis on the left. But I want more than that. We're going to go 30 more than that. So this swings all the way around in this direction. Now to get my little reference triangle, we're going to drop a side down. And remember how I said that this was 180 all the way across, right? And then plus another 30 to get to 210. That means that this angle in there is a 30-degree angle. So I'm going to redraw that picture for us, just a little bit larger. This will be a 30-degree angle. So we can use our rules with a 30, 60, 90. What I want you to remember here, though, is the all students take calculus rule about what is positive in that quadrant. In this quadrant, sine should be positive. So when I'm evaluating sine like they ask, then it will be a positive answer. Okay? So this is kind of like my work for the problem, and then I can just give the answer. So when I want sine of negative 210 degrees, that's actually all I need to do now is look at the opposite over hypotenuse. 1 over 2, 1 over 2. Double check, do I have the right sign? Yes, sine is positive in this quadrant, so my answer is positive. Okay, so the triangles are like your work in this case. I'll raise this paper up just a little. Okay, let's look at B. We've got tangent 5 pi over 3. So again, first step, draw your angle. Okay, so here we go. 5 pi over 3. All right, my initial side is right there. But tangent 5 pi over 3. So let's think about it. Pi over 3 cuts your top section into thirds. 1 pi over 3 would go this way. 2 pi over 3. 3 pi over 3 is a whole pi. 4 pi over 3, go this way. 5 pi over 3. So this goes all the way around, just like that. Okay, but remember that for our reference angle, what we want is we want this angle right in there. So in this moment, think about the pi over 3s. Those are actually indicating 60-degree angle measures for our reference angles. This guy right here is a 60-degree difference. Just like when I draw a normal pi over 3, that's 60 degrees up top. This guy, pi over 3 down here, when I connect this, my reference angle is 60 degrees. So for my triangle, if I redraw it, just try to draw it a little bit larger so we can reference it. We got 60, so I've got 1 square root 3, 2. That's our relationship. Okay, also remember, all students take calculus. In this quadrant, only cosine is positive, meaning that my answer for tangent is going to be negative. So tangent of 5 pi over 3 is going to be a negative. And then we want opposite over adjacent, square root 3 over 1, which is just square root of 3. Ta-da! So again, my pictures here are my work. All right, secant. This says negative 3 pi over 4. If you're having a hard time reading it, I was running up into this little hole in the paper. So negative 3 pi over 4. Let's do the same thing. So let's make ourselves our little quadrant, draw our angle. All right, initial side. And then we're opening in the negative direction, 3 pi over 4. So this would be 1 pi over 4, 2 pi over 4, 3 pi over 4 in this direction. Okay, but again, draw your little reference angles. This ends up being a little pi over 4 or 45 degrees. So we're looking at a 45, 45, 90 triangle. Okay. 1 root 2. This is the angle that we're working from. To get secant, remember that that is the reciprocal of cosine, which means instead of adjacent over hypotenuse, I want for secant, I want hypotenuse over adjacent. Okay? So hypotenuse is square root 2 over 1. Remember that all students take calculus. In this quadrant, only tangent or cotangent would be positive. Secant is going to be negative. So we're going to say secant of, this was negative 3 pi over 4. Remember, we want hypotenuse over adjacent, so square root of 2 over 1. And it's supposed to be negative. And really, so that's just negative square root 2. If we simplify it as far as it goes. All right. All right, guys, we got a little bit more notes here. I'm going to say let's get the notes for the unit circle because I would like to fill that in class pretty soon. So I'm going to have you guys do that part, and then we'll make one more video for these notes, and I'll have a separate video talking through all of the unit circle. That way we have everything kind of where you can go back and play what part you need. So anyways, this is all the notes that you're going to get about the unit circle here in your notebook paper. The unit circle, it is a circle that has a radius of 1, and it is centered at the origin. And so what you know is that you're going to have your sine of whatever of the angle, because it's centered at the origin with a radius of 1. The r from those relationships we had earlier, I'm going to pull them back. The r will be 1. That's why we called this an r earlier on, is because it causes this to have a radius of 1. That's what the hypotenuse of these triangles would be. So it'll be y over 1, which is just y, x over 1, which is just x. Okay, tangent doesn't have a radius in it, so it's just still y over x. And so you're seeing these relationships where basically the r is replaced with 1 because that's what the radius is. And then that gives you all 6 trig ratios. So it allows us to be able to fill in the rest of our unit circle, and it allows you to use that unit circle for other things. So anyways, that is that. And I will say I will see you guys in the next video. Okay, bye.